Okay. Okay. So what is the first question? Okay, let me just go to the answer also. So, uh, yeah, first question. How do you find this?
Using the recurrence formula, NH is equal to NH minus 1 plus NH minus 2 plus 1.
Using the recursion formula.
Yes, yes.
Okay. So let's talk about. Okay. The question is like find the minimum number of nodes in an AVL tree of height 12. So can you tell me what is an AVL tree? Hmm?
Balance tree.
You're right. Okay. Balanced tree. Hmm. Then what else is there about AVL tree?
Height of a left node H minus 1 and right node H minus 2.
Huh. Okay. Um, left node, right node, h minus 1. Okay. So you're saying something, but let's just take it here. Mm, yeah. Okay. So it's a balanced binary search tree because sometimes in binary search tree. So yesterday we saw about binary search tree. So one of the problem is that if the list is ordered, right? 1, 2, 3, 4, 5. If we get a list like
Yes.
this, so it will create a tree just like this. Am I right?
Yes, yes.
Okay.
For a
So
binary search tree.
correct. Yeah, this is a binary search tree. So this is a trouble, right? Because in order to find the biggest element, you need to travel the whole list, right? So it will be of
Yeah, yeah.
size n, big O of n. So this we need to avoid. So that's why they have come up with a new strategy called as AVL tree. Okay, so which is a balanced binary search tree, which means the tree will always be balanced. Okay, so they're talking something about the conditions for an AVL tree. Okay, so there is something called as.
Yes.
You wanna say something?
No, no.
Okay, so there is something called as slope or balance factor, which means the left subtree minus the right subtree. I mean, so slope equal to left minus right. And this should always be less than 2, and the formula for slope is nothing but left minus right. Okay.
Left minus right
Huh.
less than 2.
Yeah,
Yeah,
that's right,
okay.
less than 2. So that is the slope formula, you can say like that. Hmm, so far so good. All right. So for example, element insertion order is 1, 2, 3. um, okay. So okay, so only if I talk about these things, then only we'll be able to understand uh, the height, right? Okay. So let's
Okay.
come to this 1, 2, 3. Okay. So we are having 1, 2, 3. This binary search tree will be, I mean, binary search tree will be like this, right?
Yes.
Well, these three will be in the straight linear fashion. But for an AVL tree, first you will insert 1, right? Then
Yes.
you insert 2 on the right. Okay. So what is the slope
Okay.
of Z1? What is the slope
Mm,
of 1? It is left minus right, correct?
left minus right.
Mm-hmm. So what is the I mean, how many elements you have on the left?
Nothing.
0, right?
It's 0,
Yeah.
0,
On the right, it is 1.
1.
Okay. So 0 minus 1, which is equal to minus 1. So if it is minus 1, you don't need to do the what? Any,
Rotation.
yeah, any operations. You're right, rotations.
Okay.
Okay. So 2 we have, and we have, if you are inserting 3. Okay. Now
Yes.
3 is 0 because it doesn't have anything on the left and right, correct? So for 2
Yes.
it is left minus right, so which is 0 minus 1, correct? It has one element on the right
Yes.
now, one level on the right.
Yeah. Yeah.
Okay, so for 2 it will be minus 1, for 1 it will become what?
Minus 2.
Very good. So for 1 the weight will become -2, weight or whatever it is, the slope will become -2. So if you have a -2 slope, all right, see
Yeah.
what are they doing? So in the right hand side you have more weight, correct?
Yes, yes.
If you want to
That
balance
means
it,
it needs rotation.
correct, we use rotation. So we use left rotation, so we promote to up. Okay, so from the right hand
Okay.
side you are taking it to the left hand side. So here is the imbalance, you go to the child of the imbalance and promote it.
Mhm.
So basically 2 will come here, 3 will be on the right, and 1 will be on the left. So now this is how the AVL tree will look like, right?
Okay, that means child goes upside and parent node comes downside.
Correct, yes.
Okay.
You will learn more about this. Okay, now we are inserting 4, right? See, I'm taking this.
Yes. Yes, yes.
Okay, if we insert 4, tell me what will be the slope. You should check the slope of all the elements. Okay, so what is slope of 1?
It's 0,
Good. For 4?
0,
Good. This?
and -1,
Mm-hmm.
-2.
How -2?
Just one
Left
second.
hand side
It's
you have one layer,
1,
right hand side you have 2 layers.
-1, -1.
Correct. So 1 -2, which will be -1. So how you got 1 here? It is 0 -1, right? Yeah.
Okay.
So this is also a balanced tree, right?
Yes, yes.
Hmm. So now what's next? We are supposed to insert 5.
5.
Okay. So if we insert 5, so I'll just erase the weights for some time. Now weight will change, right?
Yes, yes.
Hmm. Okay. So go ahead. Tell me the weights.
For 5, it's 0,
0.
then -1,
Mm-hmm.
-2.
Mm. Right. And then this for 2 it is.
For 1, it's 0.
Mm-hmm.
For 2, it's
It
1,
is 1
2, 3.
minus 3.
3,
Okay.
-2,
Which is equal to -2.
-2.
Okay. So if such a thing is there, okay, so there is some rotations which is required. Okay. And
Yes.
once again, left right rotation, yeah, that's correct. Hmm. So in this case we have on the right hand side we have more elements. Okay, there was some condition checking whether it is -2, so we have -2 here. First we need to balance on the this part. Okay,
Lower part.
correct, lower part. So how do we do that?
Okay.
So 4 will go up and 3 will come on the left. Okay.
Child node upside.
Mm-hmm. 4.
So 4 up, 3 downside, and 5.
Okay.
Yes.
Yeah. Now is this balanced tree?
Balanced. For we
So
need to check slope.
yeah, check the slopes. So for
0,
4 it
0,
is -1. No, 4 it is 4 also 0, right?
0, 0.
Mm-hmm.
Yeah.
So for 2 it is
1
1 on
and
the left hand side and 2 levels, right? 2 levels are there on the right hand side. It's equal to -1.
okay.
Okay.
So
So
it's
now this is
balanced.
a balanced tree. Got it?
Yes.
Good. Uh, Fine. So there is. So we saw the left rotation, and I'll show you right. Hmm. So as we saw, if 1, 2, 3 are here, so these are all the weights. We did a left rotation, correct?
Yes, yes.
Okay. Now if we had 3, 2, 1, okay. So 1 will be on the
Yes.
left, 2 will be on the center, and 3 will be on the thing. And they have written the slopes here, right?
Yes, yes.
2, 1, 0. So we do a right rotation. Means you take the parent, like 2 gets promoted and 3 will come to the right. Got it?
No,
Same way.
no. 2 goes upside and 3 comes downside. Yeah, yeah.
Okay.
Okay, okay.
Yeah. So this is called as right rotation. And so you have something called as right left rotation. Okay. So if we have 1, 3, 2. So 1 you have only one node. Okay, then you're inserting 3, which means like this. Then you're inserting 2.
Mm-hmm.
Okay, so this is how
Mm-hmm.
the tree is. Is this balanced? No, right?
Mm-hmm.
Okay, I'm coming back to the question again.
How to check this one?
Yeah, yeah. Okay, so we have the tree, like, 1 is here, 3 is here, and then 2 is here. Okay, so
Yeah.
tell me the slopes. 0.
4, 2, 0,
Hmm.
0,
No, it's not 0 here, right? 1 minus 0, which is equal to
1
1.
minus 0, 1, 1.
And here it is 0 minus 2,
0 minus y2.
because 2 layers you have. This is the 0th level, first level, second level.
Okay.
Number of levels you have below 1. Okay, even if you have some value x here, it is still 2, because you have only 2 levels. Correct?
Okay, okay. Here we check levels.
Levels, yes.
Okay.
Okay, so 0, always we check the levels only. Okay, 0 minus 2 will become minus 2. Okay.
Yes.
Okay, so in this case, so we have on the right hand side we have more. And if we try to do this, okay, so how do we do this? So they are
Positive.
saying, if slope is minus 2, I'm sorry, yeah, if slope is minus 2, check the slope of the right child. So if slope is minus 2, check the slope of the right side. If it is positive, then apply the right rotation. Now it is positive, right?
Mm-hmm.
Hmm? It was minus 2, and here it is positive. Now apply right rotation on the right child node, which have minus 2 slope, and then left rotation on the node which have minus 2. So you should apply right rotation on this part. Okay. Okay, so when you, okay, I'll take the points. Okay, I'll write it here. Okay, if you have minus 2 as slope. Okay, which are you here?
Yes, yes.
Okay, if you have minus 2 as slope. Okay.
And
um,
right child is positive.
type here. Yeah, if you have minus 2 as slopes, and right child is positive, hmm? uh,
Yes.
yeah, what are you supposed to do?
Right rotation.
Do right rotation. So is it right rotation or left rotation? Yeah, right rotation on the right child. Okay, right child. Okay, so which means that, so you remember what is the right rotation and what is the left rotation?
In right rotation, go- it
Okay,
goes upside.
see, if we have like this, so here to here, if you're doing this, what is this? Is that right or left? So left rotation means you're taking the value towards the left. Correct?
It's a left rotation.
This is left rotation. Okay, right rotation means 3 to 1, and this one you're
Clockwise.
taking towards the right. Correct?
Yes.
This is right rotation. Now they're asking you to do a right rotation on the child. Okay, if you do a
Mm-hmm.
right rotation on the child, what will happen? So 2 will go up and 3 will come down. So it will be like 1, 2, and 3. Okay,
No, no, wait a second. Three changes from one or two?
from 2. I'll show you. See, not here. from 1 3 2, do a right rotate. See, where is that? The slope of right child, then apply right rotation on the right child node. So for this child, you need to, for 3 you are doing a right rotation, not for 2. Okay.
Okay, okay, okay. We
Hmm.
here rotations according to three.
Correct. Yeah, we do a right rotation on 3. Okay.
Hmm. Okay,
Hmm. So the child will go up and 3 will come down. Whatever is on the left will be on the left. Okay.
okay.
So in order to clear it much more clearly, so I have x on this, y and z. Okay. So I'll write it here: 1 3 2 x y and z. Okay.
Yeah.
So after doing a right rotation on 2, how will it look like? So this 2 will get promoted and 3 will go on the right, correct?
Yes, yes.
2,
One,
3
two,
will go on
then
the right.
three,
Whatever is right
then
of the
two,
3, it is there only, z. Okay.
set.
So on the left of 2, you
Here
have x.
X and Y.
Okay. And towards the left of 3, I mean towards the, sorry, uh, yeah, so this value, this y value is greater than 2, correct?
Yes.
Okay, which means it will come on the right hand side of this. Yes or no?
Yes, yes.
Okay. And it is less than 3, so it will come here. Okay.
Okay. Yeah.
So you did a right rotation. Now after doing the right rotation, you should do a left rotation. Okay. After
Yes.
doing right rotation, then do a left rotation on the node which have -2 slope. So -2 slope is on 1, correct?
Yes.
Now do a do a left rotation. So left rotation
Left
means,
rotation. Anti-clockwise.
anti-clockwise. So
Two
so
goes
2 will go
outside.
up. Okay. 1 will come
Okay,
on the
then
left.
one,
Then
three,
3 z
Z,
y.
Y.
This is okay. And where will x go? We can see that x is less than
Less,
2
less
and
than
greater
two,
than 1.
greater than one.
So x should be less than 2 and greater than 1. It will come here.
Okay.
Okay.
Mhm.
Yeah. See, this might look like kind of confusing for you initially, but you need to know this. Okay.
Okay.
So this is right left rotation. Let's recall what happened. If the slope is -2, okay, for the parent
Yes.
and the child node is positive,
Positive.
you do a right rotation first, then you come to the left rotation
Okay. And right rotation on the child node and
on the
left
parent.
rotation parent node,
Correct.
which have -2 slope.
Yeah.
Okay.
Good. So we also similarly have a left right rotation. Okay. This is very
Okay.
very similar. See, 3 1 2 is there. You do a left rotation. So what does it do? So if the slope is positive, okay, and the child is having negative, apply left rotation on the child. Then you do a right rotation.
Okay.
Just the opposite of what
That's,
happened earlier.
oh, yeah, yeah, yeah.
Okay.
Yes.
Okay.
All right.
So yeah, that's the first. That's one thing. Okay. Another case, if left child shift on parent, then position of 6. Okay. Mhm. Okay. So once again. Hello. 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 Hello, Pooja, am I audible?
Yes, yes.
Sorry, there was a power cut, so I just shifted to my mobile phone. Right?
Okay, okay, no problem.
Yeah. So tell me when my screen is visible.
Yes,
All right, cool. Hope you were following what was happening, right?
yes, yes,
Okay. So they have given us an example case here, right?
yes.
Hmm. I just take this. I believe it is still recording. Give me a second. See here. All right. Am I audible?
Yes, yes.
Okay. So something happened. Okay. So we have 7, 9, 5, 6, and 3. Okay. So is this a balanced tree? 0, 0, and this is going to be
Zero,
also 0, right?
zero,
Correct. For 7. So on the left you have two levels.
two,
On the right you have.
and right one, one,
So the slope is 1. Okay. For 9 it is 0. Correct.
zero. It's
Yeah.
balanced,
So this
right?
is a balance. So all the slope is less than 2. Correct.
Yes,
If any of the slope is you know plus or minus 2, so it's in unbalanced. So we are adding one more node here. All right, that's what they are doing. So they are adding 1 at this point. Okay, Puja.
yes, yes,
Hmm. So if we do that, what will happen? Some imbalance will happen. So tell me.
yes.
0
Zero, zero,
for 3. For 3 it is
zero.
no.
No, it's one, one, one.
Ha. For 5.
It's one. For five, it's two minus one, one,
Yeah, 2 minus 1, which is 1, right?
one.
Hmm.
For seven, it's three minus one plus two.
Ha, good. Plus 2 and this one. Okay, so now you have the parent is uh, positive, right? On the left hand side also you have positive, right?
Yeah.
Hmm.
Yes.
So if this is the case, it's very simple. Just do a right rotation. Okay, so from the greater level, you just need to do a right rotation. Simple. You just take this up. Okay?
Right rotation.
Ha. Just do one step, nothing else. You don't need
Because
to do two steps.
because here child node is also positive.
Correct, correct. Parent and the child have the same
Same
sign.
sign.
Correct. So where will 6 go now?
Okay, so when we have two rotations, when we have opposite sign,
Correct. Okay.
five, seven, nine,
Hmm.
three, one,
Do you understand here? Where
less
is your doubt?
seven, five. No, no, it's okay.
Fine. Hope that is clear. So they are giving another case, So in this case also, like, see, the sign is same. So you do a left rotation here. Got it? See this? Minus 2, minus 1.
Yeah,
Correct?
same. Yeah, so here we need left rotation.
Yes. And yeah, for example, element insertion order is 5327861. Okay, how do you draw the tree? I think they're gonna insert everything and draw it. Let's confirm that. Yeah. So this is the final AVL tree, but we'll try to draw that by ourselves. Okay.
Yeah.
So I'm taking the order. Okay. First we need to what? 5. Correct. Then
Five.
where will 3 go?
Right side.
Hey.
Left side.
Uh,
Left side.
yeah, yeah. Something is happening to my cable of my, pen tablet. Hmm. Okay. 3 will go on the left side. Is this tree balanced? See, after every insertion or deletion, you need to check whether it is balanced or not. Okay.
Okay.
Yeah. So 3 you're inserting here. So is this balanced?
Yes.
Okay. Then after that you insert 2. Where will 2 go?
Downside 3.
Correct. So 0. For this it is 1. For this it is 2.
And
Correct.
2.
Mhm.
Yes.
So what do we do?
Right rotation.
Correct. So from left you take it towards the right. So 3 will be promoted, which means 3 comes up. Then
5 right side, 2 left side.
so is this balanced?
Yeah.
Correct. Okay. So 5 3 2 has been inserted. Correct. So then we have 7. So where will I insert 7?
Downside 5.
Correct.
After 5.
Mm-hmm. Then now is this balanced?
0. 0, 1. 2 minus 1, 1. Yes.
Yeah. So then I insert 8. Okay. So
Yeah.
does this look balanced?
3 minus 1, 2. No. It needs left rotation.
Yeah. So let's first check the signs and all.
Yeah. Yeah. 0,
Okay, I'll take a different color.
1.
0. 1 or minus 1? Left
Mm,
minus right, na?
yeah. Minus 1. Left minus right. Minus 1.
Yeah. Okay.
0 minus 2.
So which will become
Minus 2.
minus 2. So you have the imbalance here.
Yes.
Okay. So imbalance is not in the parent. So let's say like so if we have a parent, so this will become what? This is also minus 2. Correct?
Yes.
And left minus right, na? Left you have 1 minus on the right hand side you have 3
1
layers.
minus 3. Yes,
Okay.
yes. Hmm.
Okay. So you have the imbalance at this level. Correct? So first
Yes.
you balance this lower part. So you have minus 2 here and minus 1 here. Same sign, right?
Yes.
So how do you balance this?
Left rotation.
Mm-hmm. So 7 will go up, correct? 5 on the left,
Yes.
8 on the right.
8 on the right.
You don't need to do the rest of the things.
Then
First you
3 and
change the
2.
imbalance at the bottom. Okay, now you have changed this, correct?
Ye- Yes.
Okay, so now tell me what is the weight. Now check for the balance.
0, 0, 0. Then 1 minus 2. It's minus 1.
Unbalanced. See?
Balance tree.
Okay.
Yes.
So if you're balancing on the right, it is the above part is also getting balanced. Okay. So far,
Yes.
did you understand?
Yes, yes.
Good.
Now we need to
8
insert
is also
6.
inserted. Now we need to insert 6. Where will 6 get inserted?
After 5.
Right of 5.
Right side of 5.
Hmm.
Yes.
So let me just erase all these things and let's check the weights. All right.
Yes.
Tell me, weight of 6 is
0, 0 minus 1 minus 1.
good. So you have 2 layers on the left and 1
It
layer on
is
the right.
0. Yeah, it's 2 minus 1
Hmm.
plus 1.
1. Okay. So you have 1 layer on the left, 1, 2, 3 layers on the right.
1 minus 3 minus 2.
Now see, you have
Minus
minus 2
2
here
plus 1.
and you have plus 1. So you have two different signs, right?
Yeah.
So what you need to do?
Firstly, right rotation, then left
Very
rotation.
good. First you do right rotation for the child. Okay.
Yes,
So how will
for
it look
7.
look like?
Right rotation.
Hmm.
5
So
come
5 will go
upside.
up, correct, and the right will. Okay, tell me.
5,
Hmm.
then 7, then 8.
Okay.
And left of 5, 6.
Left of 5, not 6. Left of
No,
7
no,
is
no.
6.
It's less than 7.
Hmm.
Yes, yes.
Okay. So we have put it here, and then so you just do the remaining things. Okay.
3 and then 2.
2. So you
Yes.
have done the right rotation, correct? Now after this you need to do what?
Yes, yes. Uh, After this, we need left rotation.
Correct. We need to do the left
Parent
rotation
node
because
3.
just doing the right rotation, it's not resolved, correct? I mean, you see the
Yes,
weights
yes.
now. If you see the weight, zero,
Yes.
0, 0, 0. So left minus right. This is like 2. I think minus 2,
Mm,
correct? And this is like
yes.
minus 2. So now you have both of same sign, same sign, right?
Mm,
Hmm? When you have same sign, you just do the other one. So 5 goes up.
left rotation.
Hmm.
3 comes down,
5 goes up. 3 comes down.
then 2
Hmm.
and 7, 6, 8.
8. Okay. So this is what we
Okay.
have now. Then at the end, we are supposed to insert what? Okay, now you check whether this is
1,
balanced. Is this balanced?
0, 0, 0, 0, 1, 2 minus 2, 0. Yeah, it's balanced.
Very good. It's balanced. So now we are going to insert 1. Okay.
Yes.
1 is getting inserted here, right?
Left side of 2.
Hmm.
Yes.
So now let's write the weight 0,
1,
1. Here it's 2.
2.
Okay. So since you have 2 here, first you do rotation here. All right.
Okay.
So what will happen? This will go on the left, correct?
Here we need a right rotation.
Right rotation. I'm sorry. Yeah. Okay. So if you do right rotation,
5,
what will
7,
happen?
6.
2
There.
will go up, correct?
2 goes
Hmm.
and yes, yes.
And 3 will come on the right
2,
of 2,
3
and 1 will come on the left
and
of
1,
2, correct?
2.
Okay.
Yes.
Now you have done this. Now see the balancing.
0, 0, 0, 0, 0. And you have 1, 2, 1. It's balanced.
Good. Balanced. Okay. Now let us check this. If we have got the same tree. So we have 1, 2, 5, 3, 7, 6, 8. Okay. We got the tree, correct?
Yes.
Great. You understood how it is happening?
Yes, yes.
Very good. Okay. So this is how you insert inside of an AVL tree. Got it?
Yes.
So basic things is done. Okay. So you have got now you have got the very good idea of what is an AVL tree. Okay. So
Yes.
let